And from the other side of 0, what do I write?
Positive infinity.
Great job. So what is the conclusion for the limit from either side of 1 of f of x?
D&E.
Thank you very much. Awesome. Well done. Any questions? So please remember, when you have this situation, either side, and a number over 0, you have to calculate and determine both. You cannot conclude anything before you show both limits, from the left and from the right. Well done. Okay, moving on. Yes? Any questions? Limits using, you can stop me anytime, of course. Limit laws. We have many limit laws. So preliminary or assumptions, assuming, extremely important, that the limit of f of x as x approaches a is a number, let's call it L, and the limit of another function g of x as x approaches a exists and is another number m. These are exist. These are numbers and they exist. They're not infinities. In general, L and M. Okay, let's start with the first limit law. Limit from f of x plus g of x as x approaches a from either side. What do you think this equals to? No, we are not distributing the limit operator. It looks like it, but we are not distributing the limit operator. So do not say distribute. So this is limit of f of x as x approaches a plus limit of g of x as x approaches a, and then that would be, what is the first limit? And what is the second limit? M. I like to present these two together because they are together. If I have minus here, then I have minus here, then I have minus here. This limit law is applicable only if these two have limits that exist, right? If their limits exist. Otherwise, the limit law cannot be applied. So here's an example. Oops, I don't know what, did I mess up this?
No, you should.
Sorry about that, I touched it. Okay, so I'm on page 7. Here's an example. Limit of 2x plus 1 over x as x approaches 0 from the right. My question is, can I write the limit of 2x plus the limit of 1 over x as x approaches 0 from the right?
I would say yes, because it follows the same patterns with f of x and g of x.
Why?
The limit of 1 over x does not exist.
It exists, is positive infinity, but it's D&E. You're right. I will not say it's D&E, I will have to say infinity. But as long as either one or both are not numbers, the limit law is not applicable. So I cannot write limit of 2x plus limit of 1 over x and apply the law that we just saw, because the assumption is not fulfilled. This limit is 0, but this limit is infinity. And that's not allowed. Is this okay? Is that clear? Okay, next, number 2. Limit from a constant times a function. as x approaches a from either side. So the constant, as long as it's a factor, okay, not plus or minus. A factor means multiplication. As long as c is a factor, it can be taken outside. So this is c times limit of f of x as x approaches a. Third, limit law. Limit from f of x times g of x as x approaches a from either side. What do you think? What do you think this will equal to? It's okay if you're wrong. We all make mistakes, and you may have not seen this before, so it's okay. What do you think? Wild guess. What do you think? Anyone?
The limit of f of x as x approaches a times the limit of
Absolutely.
g.
Okay, I forgot to write here c times L because this was denoted by L. So x approaches a, x approaches a. So what will this equal to?
L times n.
Excellent. Very good. Number 4. Next, limit law. Of course, what do you expect the next one to be? Okay. What do you think this will equal to? Limit of f of x as x approaches a, limit of g of x as x approaches a, which will be L divided by m. But there is a big if here that I didn't have before. What is the if?
If the g of x isn't 0?
The limit, you mean?
Yes.
Yes. If the limit of g of x as x approaches a does not equal 0. Of course. Absolutely. Any questions so far? Number 5, the limit of a constant as x approaches a. What do you think? Wild guess.
Constant.
Excellent, of course. Makes sense. Very good. Now let's take a look at number 6. If we have the limit of f of x raised to a power n as x approaches a from either side. And let's say that n is a positive integer, because otherwise we get into other situations. So this is something called, I like to call it, the swapping operators. Swapping the operators. What operators? Remember, this is one operator, something that is applied to a function. This is one. And this is the other one, something applied to a function. I'm going to swap them. Which one is in and which one is out right now? Which one is the inner and which one is the outer operator?
Is m the inner?
Exactly. N power n is the inner. And the limit is the outer. I want to swap them. I want the limit to be the inner. I want the power to be the outer. This is possible, and we're going to talk about it in this chapter, only because this situation is a continuous function. And I'll put in parentheses, only if continuity is satisfied. I don't need to think that this is always allowed and always possible. Only if continuity is satisfied. Okay, So then I have this. What is this? How much?
That's L.
Very good. Excellent. Number 7. We have the limit. The nth root of f of x as x approaches a from either side. Of course, n is positive integer. And you could say, what are you talking about? This is the same thing with number 6. Power n, right? Index n, very similar. We're really talking about the same situation, swapping of the operators. Limit of f of x as x approaches a. Of course, under continuity, has to be satisfied. And what will be the final answer here? Anyone?
It would be the square root of L, or the nth root of L.
That's it. Awesome. That's all I need you to say. Okay,
Do
number...
we need to define L as being a positive number, or it doesn't matter?
It's a very good point. It's a very good point. So assuming that this is a positive number, otherwise I'm in trouble, right? So if n, very good point, if n is odd, I don't care. Anything goes, anything. But if, very good point, if n is even, then L must be greater than or equal to 0. Absolutely. And the function itself has to be greater than or equal to 0. You cannot apply an even root on something that is negative. Awesome. Thank you. Great job. Okay, number 8, which I really don't like to put it as a law, but anyway. Limit of x as x approaches a from either side. So 8, 9, and 10 are really common sense. What do you think this is? What did we say? What we always have to do when we calculate limits?
A.
That's it, of course. Limit as x approaches a from x to the nth power. Of course, n is positive, integer. What would be the answer? Same thing. Anyone? What did we say we have to do every time we calculate a limit?
It's going to be a to the n.
Excellent. And last one, limit as x approaches a from the nth root of x. Of course, n is positive integer. What will you say? This is n. I'm sorry, but this is my n and this is my m. What will I have to write?
The nth root of a.
That's it. Awesome. Good. So now let's look at a few examples. Let me share my screen. Okay, where are you guys? You're here. Sharing my screen. Okay, perfect. Exercises right here. I did not manage to finish. I still have to talk about the squeeze theorem, but we are ready to work on a lot of other problems. I know I have, what do I have? I have 5 minutes left. Okay, I just looked at my phone because it's the only time that is. Okay, so all these are clear? I just want to go directly to these problems, evaluate the limits, this set, 11 to 34. You choose whatever you want from 11 to 34. Which one would you like to start with?
How about let's do 27?
27 it is. Yes, thank you for reminding me. So to show rationalizing. Okay. 1 plus t, the square root of 1 minus t. I'm going to stop sharing in a second over t. Perfect. Perfect pick. Thank you. Okay. So I'm asked to find this limit. What would be the first step? Mandatory step.
Rationalize.
Appalling step, but I have to do it first. There is an appalling step and everyone says no, but we have no choice but do it first. What is it?